Hello my dear friends, today I'll explain to you how we can convert decimal system to the octal system and then back octal to decimal. So please subscribe my channel as a request. Okay, now let's coming to the topic, like decimal to octal conversion, decimal to octal, then back octal to the decimal. We are having the different systems. Binary systems, it is, based to only two figures or digits are used, which are 0 and 1. And all of the binary algebra uses only the two digits, 0 and 1. Now we are having the next system, octal system, is the base 8. And we are having, the 8 digits like 0, 1, 2, 3, 4, 5, 6, 7. So they are total 8. Then decimal system already we know and we are familiar about it. And they are the 10 digits. Now we are having the hexadecimal system using the 16. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. They are total 10. Okay, then A, B, C, D, E. 10 up to here, 11, 12, 13, 14, 15. Then E after F. Okay, that is 16. They are the total 16. Okay, but for today, we'll discuss the octal system and the decimal systems, right? Now let's taking an example, the conversion of 127.5625. So this is the, decimal system, and we have to convert it into the octal. Octal means the base 8. So let's consider only the integer part first. Integer part is 127. Now go on dividing 127 by 8. 127, go on dividing by 8. So like, you multiply 15 by 8, that becomes 120. And the remainder will be the 7. So 8, 15, 120, remainder 7. Likewise, 818, remainder 7. 800, remainder 1. So go on dividing till the 0 comes here. So this will be the most significant bit, and this is the least significant bit. Okay. And firstly, we'll write most significant, that is 1 to 7 of decimal system becomes 177 into the octal system. Now we consider the fractional part, 0.5625 of the decimal system, and we have to find what it is in the octal system. So what to do? 0.5625, go on multiplying by 8. Just do the multiplication. What becomes? So what becomes? It becomes, 4.5000. So okay, 8 multiplied by this equals to this figure. So this is the integer and this is the fraction. Now this fractional part again multiplying by 8. So again multiplying by 8. So 0, 0 is, like now the total value is this 4 point something. Now you go on multiplying by 8 till the 0, 0, 0 left here. So then you finish up the multiplication when you find all the zeros. Okay, now you know what it is, what the result is. Now this is the most significant bit. This one is the least significant bit. Okay. So how we write the results now? So 0.5625 of the decimal system now becomes this 4, then this 4. And you know the you have to write the decimal also here. So write the decimal point also here, okay? So the result is 127.5625 decimal in decimal systems. It is 177.44 into the octal system. This is the conversion, how we convert, you know. Now the back calculation, if we are having the octal system 177.448 and we have to convert it into the decimal systems. So what's the procedure? Write the integer first of all. So 177, go on multiplying by 8. 8 raised to power 0, 8 raised to power 1, 8 raised to power 2. 8 raised to power 0, 8 raised to power 1, 8 raised to power 2. Multiplying, go on multiplying by, go on multiplying by 8 raised to power 0, 8 raised to power 1, 8 raised to power 2. Go on multiplying by 8 raised to power 0, 8 raised to power 1, 8 raised to power 2. Now what you'll get? The 64, 56 and 7. Now just the addition. Just adding up all. That becomes now coming to the the fractional part. Now this is the fractional part 0.44 of the octal system, and we have to find this value in the decimal system. Now what's the procedure? Now write down this 4 and 4, then what's the procedure is, go on multiplying 8 raised to power minus 1, 8 raised to power minus 2. This is 8 raised to power minus 1, and this one is 8 raised to power minus 2. Okay, then simplifying. So this is, remember how we solve the fractional part. So 1 over 2 plus 1 over 16, it becomes 0.5 plus 0.0625. So just adding up, it becomes 0.5625. So 0.44 in octal system becomes 0.5625 in the decimal system. Now hence 177.44, in the octal, the result is 127.5625 in the decimal system. Now we take another example, 287.684 in a decimal, and to find its value in the octal system. Okay, now 287, go on dividing by 8. So 35 and 35, 8, and remainder becomes 7. 8, 4, 32, remainder 3. 800, remainder 4. The result is 437. 4 is the most significant bit and 7 is the least. So the result becomes 437 in the octal system. Now the fractional part of the decimal system was its value in the octal system. So go on multiplying by 8. So go on multiplying, it becomes 5.77472. Now you just multiply only 0.72, not with 5. So this is 3.776. Now just again multiply only 0.776, not with 3. And the result becomes, it is 0.208 and the, 6.208. Again multiplying by 8, only the fractional part. So you do till the 0, you get the 0, 0, 0 at the end. If you do not get the 0, 0, 0 at the end, so you may left the, you may left it after 5 or 6 places, and the result becomes, this is most significant bit and this one is the least significant bit, that is 0.5361. Okay, no 0, 0 comes at the end, and you can left it after 4 or 5 places. Now what's the back calculation now? So the result is 287.684 of the decimal system now becomes the octal. In octal system it is 437.53615 in octal system. Now we're coming the back calculation. Okay, so what's the back calculation? So we are having now 437.53615 octal system, and we have to find its value in the decimal system. So first of all, 437, go on multiplying by 8, 8 raised to power 0, 8 raised to power 1, 8 raised to power 2. This is a procedure and remember it. Now then find the value. This is 256, this is 224, this is 7. Now adding up all, that's becomes 287. So this is very simple. Now we're coming the the fractional part in the octal system. This is 8. Now write down each digits like 5, 3, 6, 1, 5 separately, and go on multiplying 8 raised to power minus 1, 8 raised to power minus 2, 8 raised to power minus 3, 8 raised to power minus 4, and 8 raised to power minus 5. So multiplying with 8 raised to power. So this becomes 0.625. The second one becomes, this is 0.046875. This becomes 0.01171, and this is just a calculation and you can do very easily. There's no problem to you. So go on simplifying it, and after simplifying, adding up all the numbers, and adding up all the numbers, you'll get, now you'll not get exactly the accurate value because we don't get 0, 0, 0 at the end while we was converting decimal to the octal. So the result which we are getting here is 0.6839. Now in a round off mean if it is 3, there is 3 and there is 9. 9 is more than 5, so you can write 3 as 4 and you can left the 9. Okay, if this number is greater than 5, then 39 becomes actually approximately 39 becomes 40. So the result becomes approximately, this is approximate sign, 0.684. Okay, so hence this is a back calculation. We are getting the same result as was the question. So after this I'll give some exercise to you, so please solve that exercise and write me in the comments your results. Okay, thank you very much. Hello my dear friends, today I'll explain to you how we can convert decimal system to the octal system and then back.